Students, this is Professor Kulkarni. Today we are going to start chapter number 8, manual part programming. In this chapter we will learn how to write a manual part program. For this chapter I would like to mention here, this is very important chapter in examination, because in section number 2 there is one compulsory question asked for writing a part program of a given component, which carries a weightage of 8 to 10 marks. So let us see this chapter one by one. What is a part program? That we will understand first of all. A part program is a set of instruction which instruct the machine tool about processing step to be performed for manufacturing of a part. In short, I will mention here, part program is a combination of letter, symbols and numbers. By this we write different codes in the part program, and that instruct the machine tool about processing steps to be performed from manufacturing of the part. So for perfect execution of this part program, we need a machine control unit which converts instructions given by part program into a machine level language. Now let us understand this information on desired work tool relationship. This is important for writing a part program. This is called as a dimensional information. We need a dimensional information for writing a part program, that is x coordinate, y coordinate and z coordinates of tool position, also workpiece position. Then we need information related to change of work tool relationship, that is we need to understand a speed and feed of the manufacturing operation. Speed means rotation speed of the spindle, and feed rate of the cutting tool, that we should know for writing a part program. Then also we need to know some auxiliary operations or miscellaneous functions of the machine, which are non-dimensional functions, such as rotation of the spindle in clockwise direction, rotation of the spindle in anti-clockwise direction, some selection of units to write a part program. We may write a part program in metric mode, that is in metric dimensions or inch dimensions. So these non-dimensional functions we need to write in the part program. So for writing a part program, there is a format which is called as a word address format. Word address format is a method nowadays generally used almost in all CAM softwares. Now in this word address format, there are some notations which are given, that we will see afterwards. So first of all, let us understand what is advantage of WAF. The sequence is not necessary since all information is labeled by an alphabet. Repetition is not necessary. Controller takes the information from previous blocks. In part program, blocks are called as a line of the program, line number of the program. Word address format eliminates the chances of any error. Also, it shortens the program length to large extent. Thus, it solves a lot of valuable time in preparing, editing and debugging the program. Types of part program. These are two types of part program. First one is a manual part program. Second is the computer assisted part program. Manual part program consists of writing of a program manually. Computer assisted part program consists of some inserted features of part program. Some commands are suggested by a computer directly, or it also has some provision on the machine to generate a part program directly. For this purpose, some CAM softwares are also used to generate a part program. In this chapter especially, we are going to understand a basic procedure to write a part program. Now, common format for a block. Block means a line of part program. So in the line of part program, first of all we have to define number of the line, that is called as a block number. So here in this diagram it is shown N50. So N50 indicates the 50 number line, 50th number line. Preparatory functions, that is called as a G codes. So these we have to define secondly. This has a second preference. Then we need to define x coordinates and y coordinates. Then we need to define feed rate, that is indicated by F. Then we need to define spindle, then tool number by using capital T, or we can define change of the tool by using M codes. The M codes are called as miscellaneous functions, which are directly related to machine operations. These are not related to manufacturing operations, such as a coolant on, coolant off, spindle rotation, rate, then spindle function, then tool function, and then miscellaneous function. So this is explained here that I have told you. Now we will see the different types of G codes and M codes which are generally used in part writing of the part program. So first of all, let us understand what is G words. G words or codes tell the machine to perform certain functions. Most G words are modal, which means they remain in effect until replaced by another modal G code. For example, if you want to move the tool fastly, we are going to use G00 code, that is called as a rapid movement of the tool. But you want to stop this movement, you have to replace this code by another code. Suppose I will insert G01 code. So whenever you want to deactivate G code, you have to deactivate that G code by insertion of another G code. So this is an important point about G code. Now these are some common G codes. First common G code is G00, as I told you, rapid positioning mode. Tool is moved along the shortest route to be programmed in X, Y and Z direction. It is not used for cutting operation. Please remember this. G00 code is only used for rapid movement of the tool. It is not at all used for cutting operation. Next code is G01, linear interpolation mode. Tool is moved along, are going to use G01. You are going to move the tool in straight path. There is no circular path. Linear word indicates straight motion of the tool. So you have to define here initial coordinates, that is initial position of the tool, and final coordinates, that is final position of the tool. So you can move the tool from initial coordinate to the final. Feed rate. Again I am repeating, while defining G01 you must define feed rate. So we are going to learn a part program. In the part program writing we will see how to define G01 code. See, the G03 circular motion counter, G18 XZ plane, G19 YZ plane. It means that tool we will take in XY plane, tool we will take in YZ plane, tool we will take in XZ plane. Similarly G20, that is inch mode, we want to write a program in inch mode. G21 we want to write a program in metric mode. G28 return to axis machine 0, that is called as a home position. So after performing all operations of the tool will come back to its original position, that is called as the home position, or you can call it as a simply machine 0. Similarly, there are some common G codes, G90 absolute coordinate system and G91, that is incremental coordinate system. So we are going to use G90 absolute coordinate system. Means what? All the coordinates are written with respect to origin. All coordinates are written with respect to one origin. In the chapter number 5, we have learned the types of NC system, that is absolute NC system and incremental NC system. So in incremental NC system, what happens, that is incremental coordinate system, what happens, each coordinate is written by considering previous point as a origin. Please understand this. Each coordinate is written by considering previous point as a origin. So every now and then origin is shifted to the next point, but in case of G90, that is absolute coordinate reference, origin will remain same till end of the program. Similarly, G95 per revolution feed rate, G94 feed rate in mm per minute. Mm per minute is a unit of feed rate, and G93 we are going to define the range of RPM. This calendar cycle we will learn. Students, this is Professor Kulkarni. Today we are going to see the next part of the chapter number 8, calendar cycle. So let us see first of all what is a calendar cycle. Calendar cycle means what? Whenever you want to do any kind of manufacturing operation again and again, so you have to use a calendar cycle. For example, in one plate you want to drill approximately 10 holes, so you need to use a drilling calendar cycle. So for any manufacturing operation which is repeated more than 1, 2 or 3 times, you can prefer a calendar cycle. So there are some G codes which are used for using calendar cycle that I am explaining here. So first is the G81, just see the line number 2, which is the drilling calendar cycle. G83 peck drilling calendar cycle, G84 tapping calendar cycle, and G85 boring calendar cycle. So these are the 4 types of the calendar cycles. So for stopping this calendar cycle, we need to insert G80 code. So G80 code is used for stopping the action of calendar cycle. Suppose you want to stop the drilling cycle after drilling a 10 holes, you need to insert G80 code immediately. See, nowadays different buttons are also available, switches are available on CNC machine to stop the calendar cycle directly. So whenever you press that button, automatically calendar cycle is stopped. So you don't need to insert the G80 code also. Now you will see the next part of the chapter. It is different types of M codes that are used basically in part program. First is the M00 code, that is program pause. So whenever you want to pause the machining operation, that is you want to pause the execution of the program, you have to insert M00 code. Nowadays switches are also available on the machine, you can pause the execution of the program. Then M01 is an optional stop, a stop acted upon by the machine when operator has signaled this command by pushing a button. So button is available for stopping of the program. M02 is only used for defining end of the program. Stop the program when all lines of the code are completed. When you write a complete part program, there you have to define program is over, so you have to insert M02 code. Instead of spindle on, you have to start rotation of the spindle, so you have to go for the turning on the spindle. Then next code is M04, turn spindle on in counterclockwise direction, that is anti-clockwise movement of the spindle. This is a clockwise movement of the spindle M03, and M04 is the anti-clockwise movement. M05 stop the spindle. Once you complete a manufacturing operation, you have to stop the spindle, that is M05. For example, M05 is used in drilling operation. because once you remove the tool from the drilled hole, you have to stop the spindle. Unnecessarily you should not waste the power, so you can stop the spindle by inserting M05. You can use this M05 in milling operation also. M06, change of the tool. So we have a tool holder in CNC machine. So in this tool holder, different tools are located and each tool is numberized. Each tool is numberized. For example, T01 is tool number 1, T02 tool number 2, T03 tool number 3, and so on. So you have to define a number of the tools. Suppose I want the tool number 3, so you should write in the part program M06 T03. So in this way you should write a code. Writing of the part program we will see in the next part of the chapter. Then some more M codes we have to use in writing a part program, that is M08. We have to start the coolant on, because in manufacturing operation obviously we require coolant. Then M09, coolant off, we have to stop the supply of the coolant once operation is over. M10, you can start the use of accessories. M11, turn off the accessories, you can turn off the use of accessories. M30, end of the program and rewind the program. So same program is executed again and again if you use M30 code. Instead of M02, you can use M30 if you want to go for a larger production process. M41 is used for medium speed range. If RPM is not more, you can use M41 code. Now we will see this part 0, that is W, used for absolute programming mode. Usually a position on a part that all absolute coordinates are referenced to. That is, whenever you write a G28 code, you have to define a machine 0 position by using U0, V0 and W0 codes. In the same way, these 0 points are very important to return the tool to its original position. That is machine 0 or machine home position that I told you. Now next part of the program is very important. We have to select a type of part programming, that is diameter part programming mode or radius part programming mode. This is very important for writing a part program in turning or milling operation, turning or facing operation. So on the lathe machine, these two types of programming modes are usually used. So what is diameter based part programming? Value of diameter is specified. In this value, specified value, suppose in the x-axis I have specified 1 mm programmed movement. So in the actual motion there will be a 0 mm actual movement. So for 1 mm definition, tool movement is 0.5 mm. For 2 mm definition, there will be a 1 mm movement of the tool. So half movement will happen actually. But in the radius based part programming, 1 mm program, all these movements happens in radial direction only. There is no movement in a linear direction. So diameter based programming or radial based programming, these are only specified for movement of the tool in radial direction. Movement of the tool in radial direction, please keep in this mind. So all part program that we are going to learn ahead, we are going to write by using diameter based part programming. Sir, the radial direction has the length value of the actual movement, only diameter based programming. So in the next lecture we will see some examples of writing a part program. Initially we are going to start with the turning operation of the part program, or some forged components are there. That forged components are needed to be machined by 1 mm depth of cut. That also we will see. In the part program we will see the writing of part program for drilling operation, then milling operation. These we will see in the part programming. Thank you very much for listening this video. All students are requested to go to the Google Classroom and solve the multiple choice question test. Welcome back, friends. This is Professor Kulkarni from Sinhegad Engineering College, Pandharpur. This is the next lecture on examples of part programming. So today we are going to learn how to write a part program to drill a component as well as to mill a component. So drilling and milling operations, how these are carried out in CNC machine by using part program, that we are going to learn. So this is a plate which is given to us for drilling operation. So hole is to be drilled at center of workpiece. So this is the center of the workpiece and its diameter is 20 mm. The size of the plate is 100 by 100. So this is the 100 mm length. Similarly here also 100 mm length. Now we have to drill this hole. So this is at the center. So obviously this is the distance 50 mm. This is the distance 50 mm. And at the vertical side also this is the 50 mm distance, 50 mm distance. This is 50, this is 50. So I am just drawing a rough diagram to understand this operation. So all dimensions are in mm. This is a plate and here we are going to make the hole. Here we are going to make the hole. Now we have to consider a reference point where tool is to be mounted or tool is to be situated. A reference point, that is called as a coordinate. So we will consider this as origin. This will be considered as x-axis. This will be considered as a y-axis, and from this point this axis will be considered as a z-axis. Okay. So depth of the plate, that is width of the plate, is 10 mm. So we have to make the drill on this plate. Now what are the given points to us? First of all, spindle speed is given, that is 400 rpm. This is very important parameter in this. This is only given to us because we have to rotate a drilling tool by 400 rpm. So whenever we write the part program, almost there are 5 steps are common at the start, that is 907193. I will write here directly 28. Feed rate is eliminated from this program. So I will write here G, I will write here G, I will write here G, I will write here G. G90 indicates this is an absolute coordinate system. This is absolute coordinate system. I will write just explanation here. Absolute coordinates. This is all dimensions in mm, that is metric mode of the dimension. G93 indicates spindle speed range, that is given to us as 400. This is given to us. You should write this in front of G93. These points are not necessary to write in program, just for understanding purpose I am writing. And in front of G28 now you should write u coordinate, and this is, it may be called as a machine 0. So with respect to this point, all program is written, that is called as absolute coordinate system. Now we will switch over to the next code that is to be used in the program. It is M06. So M06, it is used for changing the tool. So tool number 1 we are going to select. Tool number 1 is selected for drilling this hole. This is the tool number 1, and in front of 01 you can write suppose 01. So this 01 indicates offset number. This is the offset in between tool and workpiece. So this offset you can write in front of tool number. So M06 is used for changing the tool, means on the same machine, suppose some operations are done previously before manufacturing of this job. So you have to change the tool and you have to select tool number 1, and drilling tool number 1 has the diameter of 20 mm, so that we can go for drilling of 20 mm. So this is tool number 1 we have selected along with offset 01. Now the next step is very important step. We will move the tool from this point. First of all, we will move the tool from this point just above this plate here. Means Z direction we have to write +1 coordinate. Suppose this is a plate and we will mount the tool just above the workpiece. So suppose this paper is a workpiece, and we will take the drilling tool just above this workpiece. So there is the distance of 1 mm in between this tip of the pin and the paper. So that is +1 mm distance. So before drilling operation, we always keep the drilling tool just away the workpiece. So first of all, we will write now the G00 code, and we will take the tool at this position. So that is X coordinate, this is 50 mm, Y coordinate is also 50 mm. Here I am writing G00, X coordinate 50 mm, Y coordinate 50 mm, and Z coordinate is +1, means tool is just above the workpiece. So G00 is used for what purpose? For random movement of the tool. For random movement of tool we are using G00. So tool is moved from this position to directly this position. Now next step here, from this position we have to insert the tool into the plate so that we can drill the plate. So for this purpose we have to start the spindle. This is the drilling operation. For starting the spindle we use the code M03. So M03 is used to start the rotation of the spindle, and we will write a spindle speed as 400. Now spindle is started. After starting the spindle we have to start the coolant. So this coolant is started by using code M08. So spindle and coolant both are started. Spindle and coolant are started. I am writing this explanation just for your understanding. You don't need to write this explanation in examination. Now spindle and coolant is started. We will insert the tool by using the code G01. So use the code G01. Now G01 code is used. The coordinate X coordinate will remain same. Y coordinate will remain same. But Z coordinate will be Z -11. So depth is 10 mm and Z is the -11, means at this position. So tool will be inserted completely in this plate, and it will come outside of the plate by 1 mm. So therefore z coordinate will be simply -11. So slowly tool will be moving inside this plate. So we have completed the drilling operation now by using the code G01. Now in the next step we have to take out that tool from this workpiece. Now tool is here. Now we have to move that tool in upward direction once again. So once again I will write the same code here. So I will write the same line here, G00 X50 Y50 and Z plus 1. So inserted tool is withdrawn quickly. Inserted tool is withdrawn quickly by using G00. So tool is withdrawn from a plate. Here for this step I will write drill is generated, that is drilling operation is over. Now you can stop the spindle after this step or after this step. There is option, both option to you. So I will stop the spindle after this step. M05 is the code for stopping the spindle that we have learned in previous video lectures. Then we will stop the coolant. So keep some space in between these two, that we write by using code M09. Then we have to move the tool to its